Hey, welcome back. So this next section is all about another data structure. This time it's the dictionary. So let's first just define some basic objectives, what we want to do in this section. We want to be able to create and access dictionary data structures, as well as just explain what they are, describe how they work. We'll use a couple of built-in methods to modify and copy dictionaries. So fortunately, there's not as many we need to talk about compared to lists. We'll learn to loop over dictionaries, iterate over them using loops, and dictionary comprehension. So we saw list comprehensions, we'll also see dictionary comprehensions. And then one of the things we'll also do is compare and contrast dictionaries and lists to data structures. How are they similar and how are they different? When would you use one versus the other? And that's actually a good place for us to begin. So lists are great. We use them a lot, but there are some severe limitations. They really work to store a particular type of data or a particular set of data where things make sense in a list. Lists of, users, lists of names, lists of items. But then things get a bit more complicated if we're working with data like we're trying to model an individual instructor or an individual item in a shopping cart. There's more information that we'd want to store. So, for example, what is this information here in a list? What does it represent? It's unclear what this is. We have a collection of values, a string, a boolean, a number, a string, and a boolean, but I don't know what it's referring to. It's just we don't have enough information to make sense of it. So wouldn't it be nice if there was a way to describe this data with more detail? So here's another example. This is not a data structure in Python. This is just me kind of outlining some things we might want to store. Let's say we had a shopping cart, which would be a list. So that's easy. We could do something like, cart equals an empty list. But then each item in the cart, with what we know right now, an item might have a name like cat litter, a quantity. We have 3 of them in my cart, and a price, $19.99. How can I store that all in this cart? I could do it as a list and start off with cat litter, and then the next element in the list would be the quantity of 3, and then the price, which was $19.99. This theoretically could work, but it's really unclear. We have to know going into this that the item at index 0 is the name of the item. The item at index 1 is the quantity. It just doesn't make sense. So what we want instead is a way of describing that data and encoding more information rather than just an order, which is what a list encodes. We can use a dictionary. And a dictionary consists at its core of key value pairs. You'll hear me say that a lot. Key value. It's basically pairs of information, pairs of data, like a label. And we use keys to describe our data, and then the values are the actual data. They represent the data. So if we think of a list, we can think of key value pairs in a list. The keys are all indices. 0 is a key, and the data might be the string blue. In a dictionary, we actually control the keys on our own, and we can decide how we want to store data and under what key. Okay, it makes a lot more sense if we just look at a dictionary. So here's an example. This is all the Boolean information from this last list back here that we couldn't decode. There's string and Boolean and numbers. We didn't know what these meant. But in a dictionary, you can actually see, name was supposed to be Colt. Owns dog was supposed to, this is sad. My dog has since moved on. I should update this slide. I own a cat still. So owns cats, that's true. Number of course is 4. Favorite language is Python. Is hilarious, false, very funny. 44 is my favorite number. 73 is actually taken its place recently. As you can see though, this encodes a lot more information. Rather than just the 0th item is Colt and the first item is true, and so on, this actually explains what each thing is. So on the left, we have keys, and on the right are the corresponding values. And also notice the curly braces. So this is just one way to make a dictionary, but they are always key value pairs, and the keys and values are separated by colons, and then just like with lists, we denote the next item with a comma. So our keys are almost always numbers and strings, as you can see over here. 44 is a number, but everything else is a string. But the values can be anything. They can be another string, a Boolean, a number. They could be another dictionary or a list. And a lot of the time, what we'll be working with is more complex structures where we have nested lists and dictionaries together. So going back to this example here of a shopping cart, rather than each item being its own list, it would make a lot more sense to have each item be a dictionary where we could have, name would be equal to, and that needs to be a string. Name could be cat litter, comma, and quantity could be 3, and so on. And what we'd end up with is a list of dictionaries where each item in the list has multiple pieces of information. So we'll get to that, but let's start by just defining our own little baby list in Python. So I'm going to make a variable, and we can just call this one cat. I'll work with my cat, and we need a name. We don't have to have a name, but I'll give her a name, which is Blue, and an age, and I don't know, I think she's 3, somewhere between 3 and 4. Let's do 3.5. And separated by commas again, let's go with is cute. And she's not as cute as she used to be honest. I mean, she's not a kitten. She's aging, it's to be expected, but she's still pretty cute, so I'll give that to her. And I hit enter. If I look back at cat, there we go. Our data is in there. We have strings for the keys, and for the values, we have a number, another string, and a Boolean. So another way to create a dictionary is to use the dict, make sure I pronounce that T very clearly, could get in trouble here, the dict function, which is just like the list function or the string function, which is used to either create or convert a data type. In this case, the most common use of dict is to pass in keys and values separated by an equal sign. So it looks like this, dict, parentheses, and then whatever key equal to whatever value. Okay, so let's try that out. Let's make another cat called cat2, and we'll use the dict function, and then in parentheses, we just pass in key value with the equal sign separating it. So let's do name equals, I don't have a name for my new cat yet. I'm just calling her Kitty. And if we look at cat2, it puts name in quotes as Kitty as a corresponding value. And if we wanted to add in another piece of information, like age, just use the equal sign again, separate them by commas, and she's about half a year. And if we look at cat2 now, we have name as a string and age as a string. Kitty, the value is a string, and the age value is 0.5. All right, so that's 2 ways of making a dictionary. Totally up to you what you prefer. I typically use the first method because, to be honest, it's more similar to how pretty much every programming language does it. Well, that's not quite true. There's a couple that do something more like this, but it's really up to you. I'll use both throughout the course. It's nice not having to type quotes here, so there's one advantage to that. Okay, so now we have data in there. How do we get it back out?